we're asked to determine the value of the double integral over the region defined by R by identifying it as the volume of a solid. So first notice how we're integrating over this region here, where x is on the closed interval from 0 to 6, which is here, and y is on the closed interval from 0 to 4, which gives us this rectangular region as the region of integration. Next, notice how the integrand function f of x comma y is equal to the constant 5, which means our function f of x comma y is going to be a plane that is parallel to the xy plane. And therefore, we should be able to determine the volume of this solid using a geometric formula and not have to evaluate the double integral, though we will take a look at both methods. So looking at this graphically, f of x comma y equals 5 is graphed here in blue. If we look down on the xy plane, notice how we have our rectangular region of integration. So notice how our solid is this cuboid, a right rectangular prism, and therefore we can find the volume using a geometric formula. The volume would be equal to the length times the width times the height, or if we want, the area of the base times the height. So going back to our work, using a geometric formula, the value of the double integral over the region R, again, is going to be equal to the area of the base times the height, which we can see the area of the base would be 6 times 4, 24, times the height, which would be the function value of 5, giving us a volume of 120 cubic units. But let's also set this up as a double integral and then evaluate the double integral. So as a double integral, let's integrate first with respect to x, then with respect to y. Of course, we could change the order here, but let's just use it in this order. So the interval for x is from 0 to 6. The interval for y is from 0 to 4. And now we first integrate with respect to x. The integral of 5 with respect to x would be 5x, which we need to evaluate at 6, then 0, and then find the difference. And then we need to integrate with respect to y from 0 to 4. So we have the integral from 0 to 4 of, we'd have 5 times 6 minus 5 times 0, which would give us the integral from 0 to 4 of, this would be 30 minus 0, or 30. And now we integrate with respect to y, so we have 30y, which would give us 30 times 4 minus 30 times 0, which again equals 120. Again, this would be cubic units. So just remember that as long as our function f of x comma y, or the integrand function, is non-negative over the region of integration, then we can think of this double integral as the volume of a solid. I hope you found this helpful.